Hey everybody, thanks for taking the time to join again for another session of Office Hours here for DynamoDB. I'm Rick Houlihan. As most of you probably know already, I do a lot of DynamoDB stuff. Today, we're going to get into really deep into the data modeling aspect of things. I've had a lot of people say, "Hey, your sessions are really good. We're going through all kinds of stuff, but of course, as usual, it's always too much, right?" Well, not always, but sometimes I go through things pretty quick, and we touch a lot of subjects. And so, today I really want to focus on that single table design. What are the benefits from it? I've had a couple of Twitter exchanges recently with people that, have asked me, when are the benefits of single table and how do I get so much pushback. I think somebody said, on single table design, how do I win the arguments that people, put in my way? And again, a lot of this has to do with people's, just understanding of data modeling as a best practice in relational databases and how we normalize data and whatnot. And but it comes down to value to the business, and we spent a lot of time at Amazon, building out these design patterns because we saw systems at scale not really operating the way we expected them to operate as far as cost efficiency, for the workloads that we were deploying, and so our customers that were now embracing these concepts are seeing the same things. One of the things I just recently talked with the product manager from a large, online gaming company. They have a pretty popular title. I can't mention the company, but they had mentioned to me that they were getting rid of DynamoDB because of the cost and the complexity. And I said, well, geez, that's really not good to hear. And why is that? And we talked a little bit about their environments, and one of their biggest problems was they were setting up their sandbox environments for their developers. He said, we have 17 tables, and each one of these tables has 2 or 3 GSIs, and just setting up that environment for our developers is painful. It takes 45 minutes to an hour to deploy those tables, and sometimes even longer. And I was like, my gosh, that's got to be what are you guys running? We talked about their data models. It really came down to the fact they were using this multi-table data model. For a lot of reasons, they had kind of broke this thing up into entity tables, and it wasn't really because, this is just the way they did things, but it really came down to the way the applications used the data, and that large documents to maintain these hierarchical data structures just wasn't working for them. Right? There was a lot of, conversation about, how much the cost of the queries that they were making were running them to go and pull out big, large hierarchical documents on a per customer basis, and the types of access patterns. Right now, their users, a lot of things revolve in a video game and an online multi-user, massively multi-user, online role-playing game. You end up with things like inventory of objects, and a lot of different interesting access patterns occur. Sometimes you need to touch all the inventories of all your customers and all your players, right? I mean, I need to give them credit objects and things like this. And if you think about inventory objects and how they get added to the players, they don't get added all at the same time. They kind of accumulate inventory over time. And so if you start to create these big, large documents to kind of accommodate these relational structures, it breaks down at scale because you start to read and write, big, huge chunks of data every time you're doing anything to alter any aspect of a customer's or a player's inventory. And so this was this customer's experience was that they were their users were, driving a workload that they couldn't support effectively unless they split the data up across multiple tables and start working with things as multiple items, little items, and small items of objects and entities and things. And this caused their access patterns to fan out across multiple tables. So in the end, we went through the whole single table design, how to bring all these entities into a single container, use indexes to replace those joins. And I actually got off the phone with the customer the other day. It's been a while since I talked to the product manager, but they said they ran the POC. They still haven't done the migration, but they're estimating a 75% cost reduction, right, to use the single table design over the multi-table design. So today, what we're going to do is break down what it takes to actually do a single table design, using a set of content that was built around a schema that we introduced, several weeks ago when we did the introduction to NoSQL Workbench. And one of our specialist SAs out there in EMEA decided to take that content and kind of elevate it up to the next level and deliver a real deep dive discussion around how do you layer this model together. It's going to demonstrate a lot of different design patterns, but it's also going to demonstrate a design methodology that kind of contradicts the common belief that single table designs require a huge upfront design burden, right? That as you add access patterns that you have to redesign everything because really it's not necessarily true that that is the case. And what we'll see is a kind of layering of patterns as we build out the richness of this model. And so let's kind of get into discussing, what this thing's going to look like. Here, I'm going to go ahead and pop this use case that we're going to talk about. And again, it's going to be, kind of really modeled around an engagement I might have with the customer when I walk in. We're going to talk about their use case. What is the nature of their data? What are the entities, the relationships between those models? We're going to list out the access patterns that we need to do, and then we're going to walk through the whole process of modeling this in NoSQL Workbench, as we do every week. But this week we're going to do it a little differently. You're not going to watch me stumble around on the keyboard. I'm going to use Samane's content here, and that's going to be, by the way, that was the person who developed the content. Her name is in the data model. We'll mention her multiple times, but thank you, Samane Utter, for putting this together, because this is going to be a much more seamless presentation of single table modeling than watch me stumble around the keyboard. So anyways, this in that use case discovery phase, what we're really going to be doing is looking at talking to the customer about what is their application, what are they doing. And so essentially for an online shop scenario, this is the use case, right? And we're kind of highlighting our entities in yellow or orange here, whatever you want to have, depending on how colorblind you are, or amber. As we kind of talk to the customer, and this is what we're going to do. We're really kind of writing these, not writing these things down necessarily, but noting them, right? Customers, products, right? Customers come to an online shop. They browse through the products. That's a, first use case. I'm going to get a customer object that I'm going to be, putting some session state into, and, maybe there's some product catalog that I need to browse through. They're going to place orders for some of those products. There's another entity. We're going to, invoice for those orders, right? When I check out, there's some sort of invoice they're going to pay using some sort of discount code or gift card potentially, or maybe credit card or some other mechanism for payment. So there we've got invoices and payments. We've purchase products then get picked from a warehouse or one or more. So we have warehouses and shipments that get shipped from those warehouses to those addresses that are provided by customers. Those addresses are associated to those customers, right? So the top level entities, just from this short discussion with the customer, come down to customers, products, orders, invoices, payments, warehouses, and shipments. Okay, and so if you look at that entity relationship model, as we kind of discussed with the customer, we're going to drive into, okay, let's go to the whiteboard. Let's go ahead and box these things out. Here's all of our entities. Now, how are these entities associated to you? Well, customers obviously can have many orders, right? Orders can contain, many products. Products can, exist on many orders. So there's you could just imagine how you would have this discussion to drive, and it's a typical discussion. This is not unfamiliar to any engineer who's kind of gone through any kind of a relational design. You need to understand your data entities. You need to understand the relationships between these objects. But the big difference that we're going to kind of go through here when we go through the single table model is, how we're going to arrange that data, right? We've got, in a relational model, I've got all these objects, these entities. I'm going to go ahead and associate and define tables for these entities. We're going to, then write queries. They're going to be representative of our access patterns. I'm going to execute these queries against these tables. We're going to join the data we need. Essentially, I'm going to define, items or rows in all these tables that define these various entities, and then queries that traverse the relationships, so to speak, of those entities. In our NoSQL single table design, what we're really doing is we're taking a single table, we're loading it with all of those rows, right? These are just items on the database. They're all the rows of your table. We're going to decorate these items with attributes. We're going to have this unique item, this unique attribute to identify those items. It's going to be some sort of an ID, and we call that the partition key in DynamoDB. And then we're going to go ahead and decorate, and then we're going to go ahead and be able to query those items by partition key. And this would be if I define a simple table in DynamoDB. But really, the power of NoSQL database is to be able to group these items into relevant collections. And in NoSQL databases like DynamoDB, that first collection is really the table, and you can define kind of subgroupings of items in those tables, which are associated by partition key and uniquely identified by their sort key. And now this one-to-many relationships, other types of relational structures we're going to build into this can be represented right on the table. And so as we start to define this application that we kind of went through, we're going to start to build some set of access patterns right into the table. But as you can kind of see, and we talked about earlier, customers have more complex access patterns than, get me all the inventory for a given player, right? It's, get me all the players that have this inventory item because I need to update some, attribute of that, or hey, guess what? I need to add this item to every player's inventory because we had a server outage last night. I want to give them a credit. So there's different patterns that I might need to access against the data, and I might need then to go ahead and index these objects in different dimensions, and that's really what we're going to do. We're going to go ahead and decorate these objects with a bunch of attributes. We're going to index them with attributes that are common across those objects, and then we're going to group them in meaningful ways, either on the table or in my indexes, and we're going to query those groupings of objects, so to speak, with range conditions to produce the relevant results we're looking for, right? So I could have a table that's full of players. These players might have a bunch of objects that represent inventory objects. Those inventory objects might be decorated with a type attribute, and now I can start to query that type attribute for all the players with a given, and to get and return all the players that have an object of a given type, or whatever, or item ID, so to speak. All right, so let's go ahead and see what that looks like from the customer's perspective. Really, we have a set of access patterns that we have defined, and in that model that we just looked at, our entity model, we have, again, customers, products, we have warehouses, we have orders. Orders have payments and invoices. Orders have products that are on the order. Shipments then have products that are in the shipments, and so we've broken this down in these 16 access patterns, and we can look at all of these. Is what we're going to end up doing is walking through each one of these individually, so I'm not going to go ahead and go through each one right now, but the fundamental exercise is going to give us a result that's going to tell us what table, GSI, LSI, whatever it is that we need to query to get a given result set that we're looking for a given access pattern. What are those key conditions? What do those filter expressions need to look like to be able to produce the result that the application's actually looking for, okay? And so the first access pattern that we have is going to be, actually the first thing we're going to do is build this model in NoSQL Workbench and see what that actually looks like. So let's go ahead and do that. I'm going to go ahead and switch over to my NoSQL Workbench tool. And I've introduced this tool many times. We use it every week. Please download it. Please use it. We've had very great success with customers who've adopted, their this tool into their design process, because it really gives you a way to visualize, the data on the table, and not only on the table, but how it lays out on the indexes as well, right? Because what we're doing again is regrouping the data, and so being able to see how the data gets grouped, what the data looks like as we group it up is really important. So the first thing we're going to do is go ahead, and I'm just actually going to open up, the second step here, which gives me some entity data already on the table. And what we always do, you'll see me stumble from week to week to create these generic tables. And what I just demonstrated is one of the nice features of the tool is to be able to actually import a data model that is, and also export that data model to a JSON structure, which you can then share across your team. You can check into source control, and then just go ahead and import that into the tool. This is a partial data model that's going to support that first access pattern, that we looked at, and that was, basically get customer by customer ID. Okay, so if we look at the data that's on the table right now, and we can look at that particular customer item. In this case, now this customer has a customer ID, C hash, whatever it is, 1, 2, 3, 4, 5 in this case. We're duplicating that customer ID into the sort key. Don't necessarily have to duplicate the ID. We could use anything there, but what we really want is we want a sort key on the table, because I might have more than one item in the customer's partition. In this particular case right now, it's the first item we're sitting on the table. Over time, I might decide customers have different types of relationships, and I can actually represent the data that configures or informs me of those relationships as items that are going to live inside of this customer's partition. And that's why I want this sort key, so that I can uniquely identify additional items that we're going to spread into the customer's partition. In this model, not sure if we actually do put anything into the customer's partition, but there are other entities that we do, and we do have the access pattern that says get me customer by customer ID. Now, some systems might not necessarily, this unique ID might be something that's more meaningful. Maybe I might use an email as a customer ID, but in this particular example, let's assume that we're interfacing with upstream and downstream consumers that don't necessarily recognize email. There's a predefined ID format that we have to support. This happens all the time in an enterprise environment, right? It might be more efficient to use something that's more meaningful to the workflow as an ID, but I can't I always have to look up an email by getting the ID, whatever. In this particular example, that's what we're doing. We've got look customer by ID, and this particular item describes that customer. And there's Samane, and that's not her real email, so don't bother sending there. All right, so that's great. And let's go ahead and see what that looks like from a query perspective. If I go ahead and configure that particular access pattern and I go query the table, I could query with these key conditions to retrieve only that customer object. Now, if you're the astute user might notice that I could query by too many. I could query by customer ID. I don't need to add the sort key because there's only one item on the table. There's only one item in the customer partition. And so, yeah, that is true in this particular case. But again, maybe I add new items onto the table at some point. I don't want this access pattern to necessarily pick those items up. Maybe I do, in which case I wouldn't add the sort key at all. It gives me every item that's in that customer's partition. In this case, I'm looking for a single item, and so I would add the sort key that is going to uniquely identify the item within the customer's partition, and that's the access pattern that we've implemented. Okay. So the next pattern we're going to look at is going to be, again, get product. We're going to look at get warehouse. I'm going to go ahead and add those into the model here when we do that. But those queries are relatively straightforward. They're very simple. To the tool, let's go ahead and add those into the workbench. And we can go ahead and override our existing model, and you can see what's happening now. If we go back to the data model, I've got new attributes, right? When I add the customer, I had the entity type. I always like to specify the entity type on every object I sit on the table. It's a nice way to be able to identify what items you're looking at. When you make a query down to the database and a whole bunch of objects come back, one way to be able to populate your application layer objects is to iterate through the result set and switch on the object type, and then that way you know what to wrap it in when you hand it off to the consumer of the API that you're standing up, right? So in customer we have an entity type, we have the email, we have the name. In the product we have the detail, we have the price. We also have the entity type, and when we visualize the model now, we can see we have two types of objects on the table. We have the customer object, we have the product object, and my access pattern holds true for both. Select by customer ID, select by product ID. And again, as we start to decorate the table, we may or may not insert more items into these partitions. As a matter of fact, we probably are in the product partition because products live across many warehouses, right? There's a relationship there. So we're going to start to traverse these relationships and build this out. But what you can see here is, if I had the simplest of simple applications, which is, customer database, let me go get customer information, and then I add products into that, and then I add, other items into that. I can kind of layer these access patterns. I don't have to know every single pattern when I start designing the table. I can actually design, a data structure for the items that are associated to the access patterns as I build the table. All right, so if we go ahead and we import the next item here, this would be the warehouse item. Right now we have some additional attributes that we brought in. Right, we've got an address, and we have a detail, right, for the particular warehouse. And if we visualize the data model, we can see now that we have warehouse items that have this address, this entity type. We're going to start to push more data in there. And again, when we go back and we look for the access pattern that we're trying to support here, that's the same type of query, right? So 3 types of entities: customer, product, warehouse. We're going to access them exactly the same way with the same query conditions. And each one of these query conditions, key conditions, delivers a single item, right? Because we're specifying both the warehouse ID and both the partition key and the sort key. Now, if I apply some range conditions in here and I add some new items in there, I could get a whole different set of results. I could get many items, and we're going to start showing you that in a second here. The next access pattern that we're going to be looking at is getting all the inventory. Get a product inventory for all warehouses by product ID. Okay, so this is where we start to introduce a relational, pattern into the data. If we go back and look at the workbench, let's go ahead and import. I believe this is model 5. And we can go ahead and overwrite that. Is that, yep. So you can see we actually added a warehouse item in here for the product partition. And this is where now things start to get interesting. If we look at the visualizer, we added some new things. We added a quantity and we added a price. And so now we can go back to our data model and we can look at, we have this, oh, we didn't add the price. Price was actually on the product already, but we added the quantity attribute for the warehouse item. And this is telling me that in this warehouse, we have 50 of this item. All right, so if I want to go ahead and say, hey, what warehouses contain an item, I can go ahead and query this table by product ID, and where starts with W. Again, because my sort key up here starts with P, which is a product ID, all warehouse items are going to start with a warehouse ID because this is the warehouse in which they exist. And so this access pattern that we just described, which is, get me the, let's go back to our session here. We can say, get me a product inventory for all warehouses by a product ID. Again, query the table where the PK equals product ID, sort key begins with W hash, right? So this is this is a great way to be able to get a subset of items out of a particular partition, subset, in this case, a subset of items by type. I know that all items inside of the product partition that are warehouse items, which tell me what the inventory of my product is across all warehouses, they'll start with W hash. So let's go ahead and do that. Let's give a query that begins with W hash and by product ID. So there we go. And that could be a totally new access pattern. Maybe I never had an inventory. I never had warehouses. I never had anything. I had a customer database. I had a product database. And this could be the beginning of my online store. And so I put all my customers and products into the same table, and later on I say, wow, now I got ship products. Okay, well, I got store products. Okay, I got warehouses. I got warehouse inventory. And you can kind of imagine how I'm kind of building the application. I can be adding access patterns, and I'm not redesigning anything as you do this. This is just the evolution of your business, right? So next couple access patterns we're going to add are going to be about orders. Orders have invoices. Orders have shipments, they have payments, so this is where things start to get a little bit more complex, right? We have multiple types of entities, multiple relationships across entities, and I have multiple access patterns for all of these entities within, within this hierarchy, right? It's not just get me all the invoices for a payment, but I might say, get me all the invoices, and as you can see down below, we have others. Get me all the invoices for the invoice ID. Get me all the invoices for a given order ID. There's multiple dimensions. There's lots of access patterns that we're going to be executing across these entities. So it does help us to kind of spread these entities out into their own little items and start to index these things in interesting ways. And so let's go back to our table and let's import the next version of our model. Was that 6? Yeah, so we added a couple more products here. We've added some more warehouses here in version 6. This is really just, we've added some more customers. We've made the data look a little bit more realistic. And I know some people do this in their modelers. Some people, in this particular case, it's great because it helps us demonstrate things. I find when I'm demonstrating, when I build my models, they're simple. I don't really put multiple instances of things unless I absolutely need to. But this is great for demonstration purposes to show these full-blown models. Let's go ahead and import. I think here's where we're going to get into orders. Where do we get into orders? Why am I not seeing orders? Yes, there's an order. So now, here's an order partition. Orders start with O, and they are ordered by a customer, right? So that's the first thing we're going to do is we're going to say orders now have a partition key of O hash. They have a customer ID as the sort key, and then they order products, right? So that's the simplest form of an order. Let's go ahead and create an order. You can almost look at this like a shopping cart. When you first come in, you're going to create this cart partition. You're going to start to first when you create the cart partition, it's going to have some top level item that describes who created the cart, and then what items have been added to the cart. And if you think about this workflow, it's actually important because even when you build a shopping cart, customers don't build a shopping cart by selecting 10 items and saying add to cart, right? They build the shopping cart by adding one item at a time. And this is one of the things that some of our service teams noted. Some of them didn't have a problem with that because the carts they were creating were all relatively small, and the buckets they were creating, the customers were creating were small. But other services had problems with that because the items that are being added contain metadata that wasn't large, but was relatively significant. The number of items being added to these carts has started to exceed 1 WCU. So, a lot of their customers, and on average, they were exceeding, 1 WCU for their writes, because the more items you add, the bigger the object gets if you put it all in one object. So sometimes, in this case, it makes it for multiple reasons to just add these product items to an individual cart or to an individual order, because not only do I want to be able to get all the products for an order, but I might want to get all the orders that contain a given product, and it's a lot easier to do that if I can index the individual items within these partitions, right? And one of the things about DynamoDB is it doesn't you can't index nested properties of JSON objects. You can't index arrays, and honestly, it's not very efficient to do those things. And so we should try to avoid building big complex documents for many reasons. But indexing deeply nested attributes and arrays is not necessarily something that is an efficient way to manage your data. You do if applications use the data in bits, you should probably model the data in bits, right? And most of your applications are going to use your data in chunks. They're not going to use big, giant, documents, right? All right, so let's go back and say, so now we're going to go ahead and add a few more things into the data model here. Let's see, where are we? Yes. Okay. So now invoices and payments get added to the system as well, right? So here we have products that are being ordered. We have invoices that are being made. Invoices might end up being decorated with some sort of payment, because if you look at my workflow, I don't have anything that says select by payment ID, right? Most of my workflows around payments are get all the payments for a given invoice. We don't have any other, I don't think we have any other access for payments. So as we add payments to our orders, they're going to actually get edited, they're going to get entered on the invoice item, right? And we'll see that as we start to extend the data model. As a matter of fact, let me load one more. Right, so now we have shipments. Shipments are coming in, and we've got the pretty complex partition space here now, right? So we have the order, we have customer object within the order, we have invoices, we have products that have been ordered, and we have shipments that are being made against the order, right? So all these things are happening, but what else happens on shipments, right? We have shipment items also come into shipments. So let's load that in there. Did we get that? I keep forgetting which number I'm on. I don't think I got my shipment items in that one. Yes. So here we have, in this particular one now, let me go back to our, I've gotten way ahead of myself, and I apologize. Let's go back to our PowerPoint here. Wrong transition. So if we look at the queries, what happened? Right. So if we look at the queries that we're running here, we've got multiple queries that are executing, and what we want to do is execute the query to get all the orders of these objects within the order, right? So the data structure, and I'll go back to the data structure and we can look at that. I apologize, this is my first time through this content. Samine actually does a much better job of getting through this section. I should have done better at this transition. But the object here is to be able to get all the elements of a given order, right? So if we have these access patterns against the order, get the order by order ID, we can query the table with pk equals order ID. It brings back all of that data, right? The customer object who ordered it, the invoice that was sent, the products that were shipped, or the products that were ordered, the shipments that were made. It's going to have the that's basically the pattern that we're making here against order, against all those particular items in the order partition. So these are the queries that we would execute to get by order ID, obviously query by order ID to get the invoices. It's, again, begins with queries that are going to give us subsets of those items within those particular objects. And some of our patterns are not going to be interested in the entire collection of objects, right? Some of our patterns are only going to be interested in subsets of those objects. And, again, depending on how much data lives in these objects, we could start to exceed the single RCU that, or some of these objects may be big objects that live inside of here. We don't necessarily want to see all of that data. So it's better for us to be more selective when we pull the data in and out of these partitions, because some of these patterns don't necessarily need it. And that was one of the things, the biggest lessons learned as we went through this type of process of modeling all the data into a single table at Amazon, was that it's not so, that every single pattern doesn't need all of the data. And by doing this, it's driving a lot of inefficiency in the system. And so we wanted to get the data spread out. But then when we spread the data out into multiple tables, then the queries across those multiple tables to try and traverse the relational hierarchies become extremely expensive. So, again, replacing these joins with partitions, right? Partitions that live either on the table, or on the index, right? So, so this is a quick look at the patterns that we have on the table, right? If we talk about when you actually structure a table, you're going to go ahead and build some set of patterns that live on the table. And then there's going to be some set of patterns that are going to require us to build indexes for. But this is really kind of the first set of patterns that we're going to build are the ones that actually live on the table. And so what we're doing is creating our core partitions. In this case, we have customer partitions, product partitions, warehouse partitions, and order partitions. Okay, and those partitions contain multiple items. The customer partitions and the warehouse partitions, they only contain one item: the item that describes the customer, the item that describes the warehouse. The order partition contains many items, right? The products that were ordered, the customer that ordered it, the invoices that were sent, the shipments that were made. The product partitions contain multiple items. They contain the item that describes the product, and we're going to use that when the customer builds the shopping cart. They contain, inventory items. Where does it live across my network of warehouses? I don't necessarily want to see all of that data every time I look up a product. So again, always reasons why we want to push this data out into individual items, individual objects. Certainly, we want to start to look at where does it make sense to push it together, right? We don't necessarily always want to get too religious about maintaining all these individual objects. Sometimes if I'm always querying this stuff, like we said, when payments don't necessarily be their own items because there's no access pattern for get me payments by payment ID. There is really no payment ID. There's only payment details. And so that's where we start to, here's the invoice was sent, the payment is the details in which how it was paid, and that all happens, when I check out. So there's no real need to, have payments be their own, process. Now I may in the future require to, hey, get me all the invoices that had a gift card. And so in that particular case, there might be the need, in that case, there might be the need to go ahead and remediate some chunk of this data to be able to introduce the new, payment items. That's certainly a process that occurs every now and then. It's not so different than the altered table process in a relational database when you add a new column that doesn't have a default value, right? Maybe I need to execute some sort of stored procedure, add the column, execute a stored procedure, generate the value that's supposed to exist in these tables, and call it done. We're going to declare some maintenance window. We're going to do this process. This is no different than what you're going to see in a relational database. But in this particular workflow, we've decided that payments don't necessarily need to live in their own items because they're never looked up individually, right? So as we go forward in the model now, we're going to actually start looking at how are we going to get the data that is is indexed, right? And so that's what we're going to go back and actually show you here is some of the GSI work that we're going to end up doing to, and let me go ahead and get to the right data model here before I go back. That was... Okay, so this is it, I believe. Sorry, I just want to get caught up to where I am in the presentation with my data model before I flip back and show you what's going on here. So let's go ahead and go back. We can take a look now at our order partition. If we look at the design of the table now, it's much more complex, right? We've added many attributes. The ones that we've just recently added are these GSI attributes, right? Because in our access pattern, and let's go take a quick look back at that, the access patterns we're looking at are saying things like, okay, get all the orders for a given product ID during a given date range. I don't have a partition on the table that's going to give me that. I have things like select customer by ID, select product by ID, but I don't have, get me all the products that the customer ordered, right? I get all the products in a given order, and that's how we've kind of set up the table. So in order to be able to produce a different or alternate, grouping of these objects that support my access pattern, I'm going to have to create an index. And so what we're going to do there, and let's go back to our data model, is we're going to go ahead and add these attributes, this GSI1PK, GSI1SK. These attributes are going to be our index attributes. All these other attributes exist across our entity objects. They define our entity objects. And when we look at the actual table, we also have the table. We have this new GSI. The GSI is going to be partitioned on those GSI-PK, GSI-SK, right? So let's go ahead and look at our model and see what ends up happening now when I look at the objects. Now, so think about what our access pattern was. Our access pattern was get me all the products that were ordered in a given date range, right? So, it'd be last 30 days, could be, whatever during this week. So if I decorate the product items that exist in all of the orders with these attributes, GSI1PK, GSI1SK, and I add the product ID, right? So that becomes the partition, the new partition key of my GSI, and I add the date of the order, right, to these individual product items. Then when I look at GSI1 and I query GSI1 by product ID, guess what? I get a date range list of orders for that product. And I can go ahead and then go back and retrieve those orders if I need to. If I need to project some order information onto these items so that I don't want to go round trip back, I can use index projections to maybe project some order details onto all of the items on the order, because I know when I go to query this access pattern that by product ID, I know that I want to get some top level information about the order, maybe who the customer was, for example. So I might decorate these things with the customer ID or customer information, customer contact information. Maybe it's my marketing team saying who ordered the product in the last 30 days. I'm going to go send them, a follow-up, discount email. So, to go get more, right? Here's 10% off if you order in the next 7 days or something like that, right? So again, depending on the patterns that you have in your application, we can structure the data to be able to access in multiple ways. And one way is get me all the products for a given order. And that's your typical, hey, this order needs to be processed. Okay, let me go get all the products for this order. Let me go figure out where they all live. I'm going to go query the system for warehouse items to look for where do these things live, what warehouses, okay, where does it make sense to fulfill this order from? Let me go ahead and send shipments, okay, and so on and so forth. So as you can see, we can build an extremely complex application here with many access patterns. So again, get all the orders to a given date range, query GSI1 by product ID, where the sort keys between date 1 and date 2. We can now look at, okay, let's go to our next set of access patterns, get invoices for a given invoice ID, get all payments for a given invoice ID, right? So since payments are part of the actual invoice item, these two access patterns are, generally speaking, they're kind of the same. We decided that payments don't necessarily need to live, as their own items. We could certainly break those out into their own items, in which case, instead of just having a single item for an invoice inside of a partition, right here we have invoice 544, I could also say, okay, let me add a payment item, which could be hash P1, P2, P3, and then have many items on the end of this that would describe payments, index those individually. But since, for our particular access pattern, what we're actually looking for is just get me the invoices by ID, really. For both these access patterns, it's get invoice by ID because the invoices contain the payments. So let's go ahead and go back to our workbench, see what that data is going to look like. I believe that is number 11, hopefully. Yes. So as you can see, we added this detail attribute onto the invoice. So when a customer basically goes to check out, they create an invoice. When they pay, they add this detail. Here's the payments. Some of this payment was a gift card. Some of it was MasterCard, whatever. You can put those payment details in there. If you want, there could be maybe a background process that runs on these invoice items. Whenever I make a payment, you can have some top-level summary items on the table. Hey, how much gift card redemption was there in this time period? You could pick these objects up from streams and Lambda, and you could create new summary items on the table that say, okay, these items were pay distribution of X, right, for top level products, right? So you could then create a whole new set of access patterns off data that doesn't even exist yet, right? Using a change data capture process that allows you to add new items into these partitions and query them in interesting ways, right? So let's see. Go. So those so we go back to GSI1 now, and we can see if we query GSI1 by product ID, we get a list of product orders by product by date range for a given product. If we query by invoice ID, what do we get? We get the actual invoice itself and all the payments that were made against that invoice, right? So that satisfies those two access patterns that we just looked at in our Excel here. As we go through, we query GSI1 by invoice ID. We get the information. It's basically, again, the same query for both. This is really one access pattern. It's kind of split against two, but in one case, we're going to get an invoice. Maybe there hasn't been any payments, and I need to add the payments. So let me get the invoice, and the other is going to say, is an accounting process that's more interested in seeing the payment data. All right, so next is to go get the shipment detail for a given shipment, go get shipments for a given warehouse. What was the information that was put in on these shipments. Let me go ahead and import one more data model, go back to Workbench. And so now we can start to look at these shipments. Okay, shipments, as shipments are created, shipments have products. Okay, so we can now start to look at the relationship between, when we go into an online, into the order, right, I can get all the products that were ordered and all the products that were shipped. So this is two different workflows that happen. Shipments can occur from multiple warehouses to fulfill the order. So as we start to look at order status, we can go get all the items from the order that start with ship or SH. That'll give me all the shipments and all the shipment items. I can iterate through that result set and determine where things came from. Status of individual shipments, update individual shipment status. Again, another example of a workflow where, maybe I don't necessarily want to go ahead and, read the whole order to be able to update shipment status. Maybe in this case, what I can do is I can query, the GSI1. I can query GSI1 by shipment ID, and I can get all of the individual shipment items for a given shipment, right? I can get the description of a given shipment. The top level item, I can update its status. I have individual items. I can update any status that needs to be updated on those individual items. Because I have the top level order items that are showing me the, what was actually shipped, and that can be updated individually. Now, what we've done now is we also added a second GSI, right? Because we have another access pattern that says, get me all the shipments for a given warehouse. And if you look at the table, what ended up happening here is that shipments kind of ran out of GSI space, right? We were indexing everything just fine, GSI1. Eventually, we had more access patterns than, two types of, than two. Right? I had to access a shipment in more than two ways. I accessed it by order ID. I accessed it by shipment ID. I also need to access it by warehouse ID. So this is what ends up happening on your tables as we start to add new entities. We're going to start to potentially add new access patterns. We might potentially need to introduce new GSIs. And sometimes when we do this, again, this might be a situation where these attributes don't necessarily exist yet on these items, but maybe they do. We might need to do some modification of the data. I think if you've watched my office hours for the last couple of weeks, you're kind of getting the idea that it doesn't take very long to scan a DynamoDB table. I mean, I work with big chunks of data. Granted, it's millions of rows, and sometimes we're talking about billions of items, but even billions of items can be churned through pretty quick if you need to do some data modification, index things in new ways, right? So, and we can always add new indexes to support additional access patterns on existing objects, just like this. So we added that GSI2. Now when we query GSI2 by warehouse ID, we're going to see the shipments for a given warehouse. Now, I might say that maybe the use case for this might be get me all the shipments for a given warehouse. And I might say, okay, that might be interesting, but I would expect this data to have some kind of life cycle to it, right? It's not going to live on the table forever because that query is just going to get bigger and bigger and bigger over time, right? There's no way to, to limit the result set from this particular query because I'm saying get me everything for this warehouse is really what I'm saying. And if the shipments for that warehouse grow over time and they're never cleaned off of the table, that could become problematic. And so maybe this is like a daily process where I say, hey, get me all the shipments for this warehouse, and then I'm going to go through them all and say, okay, clear, 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 and wipe them off the table or something like that, and leave the shipments that are still in process or something. Or I want to see a TTL, so like maybe after 30 days, the data just goes off the table, because otherwise that query is going to get bigger and bigger. The alternative here is to put a date range condition inside of that GSI2 SK. If we put a date range condition on those shipment items, then when I query this, I could say, hey, give me everything in the last 30 days, give me everything in the last 24 hours, and that's going to be maybe a more meaningful query, right? So that'd be one potential improvement on the data model. So, again, let's go back, take a quick look at what those queries might look like for those access patterns. And again, it's query GSI1, PK equals shipment ID. Oops. PK equals shipment ID. SK equals shipment ID. That's going to give you the shipment detail. Give me the shipments for a given warehouse. I might want to be able to get, like we said, when we query GSI1 and I query by shipment ID, I might want to see more than just the shipment ID, shipment detail. I might want to see the products that were shipped on it as well, in which case that pattern might look a little bit more like, where PK equals shipment ID instead of adding that sort key condition, right? Because if I add the sort key condition, I'm only going to get a single item. Now, that could be your access pattern might say, hey, I want to get shipments by shipment ID, and I don't want to see the products. I might have one pattern that says that. I might have another pattern that says, I need to see the whole shipment. And it could very well be that the product items carry more metadata than you want to return when I'm accessing the shipment details. So you might have two different access patterns where, hey, get me the detail starts with P. If you look back at our data model here, let's go flip back to that. Right. If I look at, select GSI by shipment ID, starts with P hash, gives me all the products, starts with SH hash, gives me the just the shipment item. So again, in this particular example, these items are small. You're not seeing a lot of metadata. It probably doesn't matter, but in the real world, these items get big, right? So, have all kinds of information about, that you don't necessarily want to return, right? So let's make sure that when we look at the data and we build our data models, that we're really only working with the data. And that's probably the biggest lesson here, that you're really only working with the data that you want to use, at any given time. All right, let's go back to our next set of patterns here, which is get inventory for all products for a given warehouse. Get all invoices for a given customer ID, get all products ordered by a given customer ID during a given date range. All right, so we're getting pretty much to the end of the model here. This is going to, let's make sure I got everything here. I don't think so. All right, let's go back here. All right, so most of this is going to be about decorating items on the customer's order, right? Because we have, of course, get all the products for a given warehouse. That's not going to be, decorating the order. That's decorating the warehouse items, right? All the inventory items. But invoices for customer ID during a date range, giving products for a customer ID during a date range. Again, both kind of indexing the items within, the order partitions. And let's go ahead and take a look at what that looks like. So inside the order partitions, we have invoices. Invoices were already being indexed on GSI1 on the invoice ID, so we need to add that GSI2. GSI2 is going to be on customer ID, again, by date range. If we go look at GSI2, what we can see is if we query by customer ID, we're going to get date range list of invoices, right, for a given customer. We can look at the invoice status, payment status, details, all that stuff for a given customer. If I want to look at products ordered by a customer for a given date range, again, I'm looking at those order items, and I'm already indexing them by product ID on GSI1 because they exist on the table under the order. So that's probably my more common access pattern, right? And so what I'm going to do is then add that date range condition as GSI2 sort key, and use the customer ID as the partition key. And when I query GSI2 by customer ID, again, we'll see not just the orders that and the invoices, right? We'll see the payments. Now, if I have the need to add filter conditions, right? That's where we're starting to go here, is because now there's two ways to go about this. I could be selective, and I could prefix all these dates with the type, and that way I could go into the customer's partition and I could say, give me customers data for invoices in the date range, where I could say between, I hash date 1 and I hash date 2, right? That'll give me all the invoices for a customer if I prefix these keys here with the actual entity type, right? But that means that I can't get like a life cycle of the customer view. If I come into the table, because it's faceted, right? I've created, date sorted lists of items within the customer's partition. That could be useful for some access patterns, but, if I have an access pattern that says, give me all the activity for a customer over the last, 6 months, 12 years, or 12 months, whatever, then I don't necessarily want to create those facets. And the reality is, customers don't make a lot of orders, right? So they're not going to have a lot of products that they've ordered. I mean, even a busy customer, sure, you're going to have some corner cases that have large numbers of orders, and we can talk about how to deal with those. But for your average online shop, the people interacting with your website, they're not going to be placing orders with thousands of items thousands of times a day, even if you're getting thousands of orders a day. So you're actually okay with filter conditions where I say query where customer ID equals X within the last 6 months, filter on PK starts with, or SK starts with I, right? I hash. That gives me all the invoices the customers received in the last 12 months, right? So there's ways to be able to selectively parse through the data. Now the read is going to be a little fat because you're going to go read a bunch of items that you didn't necessarily return, but that's okay because the data potentially isn't being read that frequently, or the collection of items in the partition are relatively small, so the filter doesn't hurt you too bad. But again, lots of different ways to be able to carve through the data and see what that looks like. So in this particular example, if we go back and look at those queries, what we can see is that we have a partition, again, query for products of all given warehouse ID. Oh, I don't think I did show you the products in a warehouse. Let's go back and look at that. So if I look at products in a warehouse, I'm inventorying on the actual product warehouse items, right? And since warehouses are already indexed on GSI2, it doesn't really matter that they're not that the warehouse items aren't on GSI1. It looks like this warehouse item is actually missing some attributes. We can go ahead and update that real quick. Let's do that. Warehouse item, there you are. What product is that? That is, that's same product. And so we can save that. And so now if I look at my aggregate view, I'm going to see that all my warehouse items are indexed on GSI2. And that's what we're looking for. Oh, this is actually the wrong warehouse ID because he's in... So that would give me 2 warehouse items in the same. See, I knew I'd find a way to get you so you guys could watch me stumble around editing data. There you go, that's okay. And so now let's go back, look at those product partitions. We can see that this particular product has 2 items that exist across 2 different warehouses and have two different same inventory in both, but again against 2 different warehouses. If I query on GSI2 by warehouse ID, that's what I'll get. I'll get the warehouse items, the shipments that came out of those warehouses, right? All the shipments by warehouse was one of our other use cases, and I'll get all the products that are in inventory in a given warehouse. So if I want to get a given warehouse inventory, I can query GSI2 by warehouse ID, gives me all the product inventory for that given warehouse, and so on and so forth, right? So we have multiple access patterns that are executing against all of our GSIs at this point. This is one of the common patterns that we like to implement in DynamoDB and all NoSQL databases. It's what we call index overloading. Again, the only reason that, if you look back at the access patterns, the ones we designed for the table, that's about half of them. The other half were index patterns, but we only have 2 indexes. And that's because we're actually indexing those items in multiple ways depending on the item type, and we're reusing the indexes. This is called index overloading. This is one of the more valuable aspects of single table design. And so it's one of the reasons why cost drives so low in single table design. When you start to, again, let's go back to talk about the access patterns of the company that I talked about when we started all of this discussion. were creating 17 tables with multiple indexes on each table. It was exploding out to 60 or 70 objects they needed to create in DynamoDB just for a developer sandbox, right? So just the mechanics of it was killing them, when they try to develop at scale. I mean, the team had like 125 developers. When you look at having to do that and actually look at the inefficiency of the access patterns across those tables, it just becomes tremendous. And so these design models, these data models, start to become really core to the cost profile of your application. And if you want to scale your systems and do it efficiently, then we need to start to think about our data this way. And honestly, it's not so difficult, really, as we kind of walk through. We create that entity model, and and we just kind of go from there. In the beginning, so to speak, right, there is the entity relationship diagram, and that's what we're actually going to build everything off of. And there's no there's no difference in modeling. Where the difference comes in, it's like, how much data am I going to denormalize? How much of the data am I going to decorate the child objects with from the parent, so that when I make the queries for the indexed objects, I actually get the results that I need without having to go back to the table and make additional queries. And that's okay. That's exactly what the process is about. And honestly, as you start to get through putting these data models together and creating these aggregates on these different indexes, it'll become very apparent to you which ones you want to optimize by denormalizing, which ones you want to say, that's okay because it's an infrequent pattern and I don't want to pay the cost of denormalizing. And it's going to be trade-offs. So hopefully this has been a good exercise. Sorry I got a little lost in the middle there. I think we recovered the this is, again, a really representative of the exercise that I go through with customers, and it's one of the reasons why I kind of wanted to dive into this, because it kind of shows the evolution in a much better way than trying to walk through all of this and show you Lambda and show you aggregations and top-level reporting all at the same time, right? This is more of a focused, exploration of how do we actually model the data in a NoSQL database, and really represents the kind of design that we've implemented thousands of times, here at Amazon and across the customer base. And so hopefully it'll help you guys. And one of the things that we're going to be doing is next week, we're going to be showing you an implementation based on this model with some real data, and it's going to be using AWS Amplify with direct Lambda resolvers, right? We got a lot of customers that talk to us and say, hey, I want to do a single table design, but doesn't that make my Amplify blow up? And Nader David is going to be coming on and helping me with this. And he's working on that demo right now furiously, and that'll be a great session. So please come back, dial in for that. We're going to be again using this model. We're going to show you those 16, well, not all 16, but as many as we can actually get implemented, and we're going to show you that in an AWS Amplify demo next Friday, same time, 12:30 Central Daylight Time. And thanks a lot, everybody. If there's any questions, feel free to fire away. I haven't been checking the sidebar here, but hopefully the moderators have been busy. If there's any questions you guys want me to answer, fire away. All right, so I'm not seeing anything from the moderators, so can't see the chat channel. So hopefully you guys got everything out of this you guys needed. Thank you so much again for your time. Next week, dial in. We'll show you that Amplify with direct Lambda resolvers, and that's it from today from DynamoDB Office Hours. And thanks again for our moderators. Thank you, Samane, for providing this great content. And again, we'll see you all next week. Thanks a lot. Talk to you later. Bye.